Hey everyone, thanks for coming along to running everything you need on GCP if you run a SaaS. Quick show of hands, who has a SaaS that they're running, that they're operating? One person, two people, three? Okay, a few people, that's good. And who has used GCP in some way before? Okay, most of you, that's okay. You're in the right spot. My name's JK, thank you for the introduction, Kaz. I'm from Perth, so think of that what you will, but we have the better coffee than Melbourne. I'm here today to talk to you about the SaaS Toolbox on GCP. And this is really sort of highlighting all of the services that GCP offers you if you are running a SaaS, which I have one, and we can use that as part of the demo later on. So getting straight into it, there's this problem that if you have operated any kind of service before, and you don't look at the icons, they're like AI generated. You'll have this sort of tool sprawl where you might be using Genlin's servers or Jenkins servers to build and deploy your code. You might be using, GitLab or GitHub or both. You might be using a combination of your clouds. You've got alerting tools like PagerDuty, for instance, or logging monitoring tools, Datadog, that sort of stuff. And so your application resources and the places that you need to go to get things done is kind of all over the place. There's security concerns about how you get your data out of your workload and into these SaaS tools, or how they can hook in securely and things like that. So, and I've seen this because I've worked with quite a lot of startups in the last few years, and they all have some variation of this problem, especially with when it comes to security. Quite often engineers are trying to get things out as quickly as possible to meet the market demands, and security concerns are kind of left behind a bit. So you get things like security keys committed to the Git repo and all kinds of security concerns like that. So that's kind of setting the scene a little bit about all the different potential problems that you could have with all these different tools. There's also the issue of training your staff to understand all these different tools, different interfaces. And then lately everyone's been doing like an AI version of their tool. So then you have to like integrate with that and understand how that works. And it's a whole nother bit of work. But if your workload is on GCP, you should just use the tools that you've already got. And this was actually a really awesome image that it generated for me when I asked it to create a center of all of your tools on GCP, and so create this crazy cloud island, I guess. And so you have things like automation, which we're going to go into talk about all the tools, but there's automation, there's observability, there's your serverless platforms, running your workloads, all that sort of stuff. And so I guess for the purpose of this talk, I'm just going to run through an example. Just get this thing out. Sorry, Zoom's not down. Okay. So what we'll do is we'll sort of walk through the flow of building a new feature, getting it out into some kind of production or test environment, and then operating that feature or monitoring it. And so for this example, I've built a SaaS called Rocket Flag, which is like a feature flagging tool, and I built it on GCP, and so we can use that as a real world example. And if you want a live demo, you can sign up there. And yes, this is a shameless plug, but what this will do will be when I have new users register for an account, I have an alert configured, which sends me a message to a alerting channel based on a log metric. So we can see that in action later on if anyone wants to sign up. If not, I can show you a screenshot. Completely understand. So let's follow the life cycle of a feature request. This might be what a lot of software engineers deal with, but hopefully we get a well-made Jira ticket from the product manager, and they'll say, we need this thing so that it can do this in order to achieve this goal, which, we can dream. And then eventually the ticket is picked up off the backlog and the work begins. Once the work is completed, there'll be some automated tests that are written based on the specs of the ticket. The code's written, and then those tests go from red to green if you follow the TDD approach on the dev machine. And then we might push them to a branch on a remote server, which will get tested and then reviewed. And then eventually we merge the code, we deploy that code, and we have QA and test, and then finally the release. So for phase one, let's talk about some of the tools that you can use. Now, these are sort of optional tools that I put in here because it's kind of, you don't really need them, and I probably wouldn't recommend them on a day-to-day, but for definitely for short-term or in a pinch things that you might need. In the Google Cloud Console, there's a tool called Cloud Code, which is like a VS Code-like interface. It's got a pre-configured Google Cloud stuff. You can see there's a little, I don't know if you can tell, but there's a little extension there, which is Cloud Code, and it has all the GCP integrations in there. It's also got Gemini, of course, because that's Google, and has pre-built tools for Python, Go, JavaScript, etc. And you can also host web servers there if you're running a Flask server or something like that, and you want to just check it. It gives you a secure connection to like a local hosty kind of thing, which is hosted in your Cloud Shell. So these are great for like lightweight editing if you're doing cloud functions or something like that, or a lightweight change to your Cloud Run servers. But these are some dev tools that you can use, and it's completely free. When it comes to the source control and code review section of your lifecycle of your feature, Google Cloud integrates really well with GitHub and GitLab, and this is a GitHub example. But at the PR stage, you want to automate your status checks. So Cloud Build, which is GCP's CI/CD platform, can be used to automate a lot of these tasks. So in this example here, you can see that this is the output of a Terraform log, but from it you can do your CI/CD tests, you can lint your code, build Docker images, all that sort of stuff. But you might be thinking, well, I already use GitHub Actions, or I already use something else. So why should I switch? I said so the reasons for that is, one, it's another tool that you have to manage, and the security considerations which I touched on previously. If you're building an artifact, then you need to do something like a workload federated identity to securely push to your code repository or your artifact registry. If you want to deploy out to production or something like that, you have to give permission to a third party, this case being GitHub, to allow them to push into production. So you may not want to do that. So Cloud Build, which does similar things as GitHub Actions, is already running in your Google Cloud projects. So there's that less security issues to think about. Okay, so now we've merged to master branch. The developer's coding work is done, and now hopefully our automation is taking place and it gets our code out into production, which is where the fun really starts. Let's go into phase two now, which is to deploy our code. So in the assembly line, I guess you could call it, we have new code in our master branch, and it's time to build an artifact. So similar to the CI checks, Cloud Build, again, the CI/CD platform can be used to install our dependencies, create Docker images, push them to artifact registry, and then for them to be deployed. And you can see the steps there are pretty straightforward. This is for a node service. We've got our builders, cloud builders, which Google provides out of the box, and we just need to do a few steps there, give it an identity so that when you look at it in the output, it's very clear on what each stage is doing. So in this case, the first step is to install the dependencies with npm CI, and then we test it with npm test. And then the next stage on line 10 there is using Docker to build a Docker image. So we just do Docker build, give it a tag, and then we push that built Docker image to the artifact registry, which we'll talk about in a second. And then finally, we deploy to Cloud Run. So in this case, we're deploying the Docker image to the Melbourne region, and we're allowing anyone to invoke that service. So artifact registry, this is where we store our Docker images. Again, there are lots of different tools that do this, but artifact registry is already on GCP, especially if you have very, very large Docker images, which I have seen in multiple tens of gigabytes before. It can be very expensive to, in your egress costs, to pull those images across from different storage solutions into Google Cloud or the other direction. So having it, and also it takes time to pull that image. So if it's already in the same data center or region, it's much, much faster. And obviously the workloads that are running those services are authenticated. So only those services can pull only those images. So you get that kind of security authorization as well. You can go really far into this if you want to with things like binary auth, but for now, let's just talk about artifact registry. If you want to, you can also store multiple versions of these Docker images, so you can quickly roll back to an old version if you need to. And this can store all the different versions of our app. Okay, so the artifact is built, and now we want to ship it. So if you're shipping to production or to a test environment, Cloud Run's a really good option for running containerized workloads. I'm seeing less and less reasons to use Kubernetes these days, but especially if you're running a startup, I would very heavily lean towards something like Cloud Run, if not Cloud Run itself, because of the way that it's much more hands-off in terms of operational management. So you don't need a dedicated SRE person to manage your Kubernetes clusters. As you can see from the screenshot, it's very developer and ops friendly. Once you've deployed something, I'm just realizing the screenshot's a bit small, but you can see lots of sort of graphs that explain the health of your service. So in this chart, we've got request counts, so how many requests are coming in per second. We've got request latencies, so how long is it taking for your service to serve that request. So if someone's saying, hey, I want to hit this endpoint, you can see how long it's taking. The end-to-end request latency is how long did it take for a request to come into Google's network, be served by your container, and then exit the network, which is a new one. That's really nice. And then there's other things like how many instances you're running, how much CPU and memory utilization. So you might need to adjust based on your application's requirements. So this is Rocket Flag's container CPU and memory utilization, and the numbers are quite small. Unfortunately, I didn't realize how small it would be, but it's about 40% utilization, and the CPU usage is about 10%. The advantage of Cloud Run as well is that because this is a serverless platform, there's no security considerations of your compute instances to manage. So you don't need to do like security updates and patches and things like that. It's all managed for you. And the other advantage is if you're a startup, you may not always be having traffic. So it scales to 0, which means if no one's using it, then you're not paying any compute costs. Okay, operate and respond. Same picture, but with the monitoring, we get these system metrics out of the box. So we can see, is our service getting too many requests? Do we need to scale out to have more containers running? Is the memory being smashed and we need to increase our memory usage? Memory availability. Potentially, it's an indicator of needing to offload some of those requests to something else, like a managed Redis or something like that. We can now see a little bit with cloud logging and monitoring what's going on. So with cloud logging, this service might replace something like a Datadog, if you're using Datadog or some other centralized logging. But in the Google Cloud Console, you can see logs about everything that's going on in your project. There's a really nice filter on the left here in that second column, and you can filter down based on the particular service, the region that it's operating in, if it's got a service name or some kind of other metric that you want to follow. In this case, I'm looking at just information logs. You can go, I just want to see error logs, or I just want to see warning logs, whatever the case may be. And it also shows a timeline. In this case, I'm just looking at the last 12 hours, but you can go back as far as 40 days, I think it is by default, or 45 days maybe. But if you want to turn on extended logging, I think it's called, you can go up to as far back as you want to, because the logs get stored in a storage bucket, so you can analyze them going back years. And it does use a specific query language. which Google's input there is, but it also helps you with autocomplete as you're typing, and as you select items in the filters fields there, it pre-fills it for you, so you don't need to like know how it works out of the box. Then there's other things like you can drag across log metrics and stuff like that just to filter on a specific time. And then, yeah, you can get a lot of information just from this tool that already exists. The other one is the proactive alerting. And this is probably one of the most useful things, at least for me, because apart from working on this project, I also have a lot of other jobs that I work. And so I can't be checking the logs for this all the time. So this is where the monitoring comes in, and this is what I was talking about at the beginning of the talk. If anyone wants to register, we can check in a minute. But you can set up all kinds of alerts that are useful for you to know that you might be interested in or want to care about. So for instance, I have a log that says new user registered, I think it is. And a log-based metric I have set up that says, as soon as this log appears somewhere, send me an alert. So I'm interested in knowing when I've got a new user that's added, because I can then maybe want to welcome them to the platform, send an email, say, hey, saw that you signed up. Let me know if you've got any questions, that kind of thing, sort of like a nice sort of service to have. You might also be interested in, tell me in Slack if the error message, if there's any errors or the error rate's above 1% for 5 minutes. I have any errors turned on, which got noisy once, but then it allows me to be on top of any kind of errors that come through, because I want to be able to fix them as quickly as possible. But if you have operating a service that's really, really busy, you might want to say, okay, well, only tell me about errors if they're only above 1% or something like that. You might want to check if you've got a new payment, something like that, or when a health check's failing. When you set this up, there's all kinds of different notification channels that you can do. In this image here is from Google Chat. That's built into Gmail. So if you use Gmail, then you'll already have this. And then in the notification channels on the side there, I've got Google Chat as the channel type, and you can just set up alerts to go through to there. The other one I want to touch on is something that's fairly recent, and it's very, very helpful if you're in a team and you've got multiple developers committing code of which you may not be sure about what the features are that are going in, especially if you're the dedicated SRE or dedicated cloud person that's running the service. You can open any log, and then you can press the button there that says explain this log entry. And what happens is that on the side, a bar pops out with a pre-configured prompt actually from Google that says you're a Google site reliability engineer and you've got an in-depth understanding, blah, blah, blah. Explain this log. And so then what happens is the entire log's contents goes through to that prompt, and it gives you a response about what's going on. So in this case, I just happened to pick a successful one, but it says the request was processed by the revision that ran in South America West 1. So I've got some customers in Chile, I think it is, that are using it, and the region, and it returned a 200 okay, and it completed with low latency, which is just, I guess, nice to read. But you can look at the log information at the top there. So you can see that the request was a GET, status code was 200, it served 376 bytes, and it was served in 4 milliseconds, and it was from using that Chrome browser version number. So that's like kind of nice stuff that you can see. When there's an error, it's really helpful because you can ask further questions from the log explanation, and you can also ask it to try and help you resolve it. How might I fix this error? So it can be very helpful, but again, with anything with AI, take it with a pinch of salt. Sometimes it works, most of the time it doesn't, but it is helpful to sort of guide you down the right path. So some of the, I guess, conclusions or takeaways that you might want from this. This is the full picture of what we've just talked about. So if we've gone from an idea or a bug fix to a fully monitored production feature, all in the one platform. we've planned for our feature, we've written the code for it, we've built it, tested it, deployed it, and we're running the service. And now we're also able to monitor that service. So this is the DevOps helix, if you haven't come across it before, which is, so DevOps is, despite its name, is not actually a job title, it's a culture. And it's all of these things built into one sort of philosophy of planning for a service, writing the code, building it, testing it, and releasing it. There are some additional tools we shouldn't really get into in this talk, but ones that I use definitely, which can be very helpful. One of them is identity platform. So you might use various like authentication services. I'm trying to think of one. Auth0, for example, is one of the ones. It's free up to a point, and then you have to pay. Same with identity platform. It's free up to a point, and then you have to pay. But identity platform's already part of GCP. So it's one less external service to have to manage, especially with identity, because it's a secure service. You want to make sure that whatever identity you're giving out, that it's got secure resources, and then you don't have to worry about cross service trust, I guess. Cloud Trace is really, really good if you're doing tracing. So this is where you would get a request come in and you can see bottlenecks in your code or bottlenecks between services if there's multi-services or like microservices that you're running. Error reporting is like a centralized error dashboard for aggregating all your error logs. And so you can say, oh, okay, well, in the last 30 days, we've had this error appear 30 times. We've had this one appear in the last day, but it's new, so it might be related to a recent code change. It's kind of helpful to understand the health of your application. Cloud Armor, a web application firewall. So that's where you want to control what traffic actually hits your service. It's very, very useful if you are being, if people are attacking your service and trying to get things like environment variables or whatever else out of it. It's a really, really useful tool. And Cloud CDN to deliver your assets to users quickly. This is where you might want to you might be thinking of something like Cloudflare. Cloud CDN is similar in that it's a CDN offering and it's tied in with your application. So again, one less extra service and it's already close to your app. The egress costs are minimal and that sort of thing. So if you can take 3 things away from this talk, one of them, unified experience. GCP has a lot of tools already built in, and it helps with keeping your costs low, because if you have 10 of these extra tools that take away some of this work, the cost of those tools that take away all that work, as well as the burden of your staff having to learn all these tools, can sometimes exceed the value that they bring in the first place. So something to think about. And then of course the context switching and, oh, I've got to log into that tool to go check this thing and then go back to this tool to check that thing. And then by that time you've done like 3 or 4 tools just to go and try and solve this problem. And so automation. So with Cloud Build, Cloud Run, we can do a lot of things out of the box with very minimal effort, and alerting as well. So logs, log-based metrics and log-based alerts or other significant events. You can all build with the tools that you already have. Okay, did anyone register? We can check this live. If not, that's totally fine. I completely understand you don't have to sign up for a service. I just thought I'd ask. If not, if no one has, I can Alt tab out and we can have a look at an example. Otherwise, thank you very much. Let me just quickly Alt tab and see if anyone has. No alerts. Okay, that's fine. So this is what they look like. Had someone registered, they pop up in this Google Chat alert channel that I've set up. And when an error comes in, you can see some details about it. So in this case, an error popped up. Oh, there we go. Someone's registered. Thank you, whoever that was. And you can see that there was an error has hit this service, and it was on this revision, and it was in this region. So if I wanted to, I could press this button here, and it would take me straight into the Google Cloud Console where that error appeared, and then I can look into more information about that error. That you can also, there's a new thing called Cloud Investigations, which I didn't get to, but you can see this is where all the errors are showing up. So I can acknowledge the incident, I can close it, and I can bring that into the incident management if I've got one. But yeah, that's what that looks like. So I will just go back to the presentation. Does anyone have any questions for me that I could help you with? Good question. Yeah, there is a cost of, there is the concern of costs. I completely understand that. So a lot of the tools that I've talked about today are free because they are sort of included as part of the virtue of using the services that produce them. So for example, Cloud Run has a pretty generous free tier, but by using that service, you have access to the logs and the metrics and that sort of stuff. So you get all that stuff as part of paying for that service. You could pipe those logs, for instance, to an external service like Datadog, for instance, or you can use GCP's one. So the logging, for instance, doesn't actually cost anything unless you're keeping the logs for a very, very long time. And so the cost really comes down to how much you're using one of those tools. So from the list of all the stuff that we talked about, Cloud Run actually cost me like 3 or 4 cents a month to use. Like it's really cheap. And I'm using Go as my programming language. So the startup time is very, very quick, and the serve time is also very quick. So when a request comes in, you're only paying for the time that the request is actually being served. As soon as the request has been served, you stop paying. So it's, as your service gets busier, you will pay more. But it's like ridiculously cheap. I think you get 2 million invocations or 2 million requests for free per month, with some insane amount of CPU and memory, but Go being very lightweight, like it costs me almost nothing to use. The biggest cost I have is actually load balancing, and that's like a fixed cost. So I pay the fixed cost and then I don't pay any extra because it's such a small amount of traffic that I'm serving. So yeah, a lot of those services, like all the error reporting and monitoring, logging, cloud build as well. You get like 1,000 or 2,000 minutes a month or something like that. So yeah, it's pretty affordable until you go past that limit, and then it's sort of, it's not expensive, but it will grow as your business grows. Yeah, so it's, yeah. Does that make sense? And there's all kind of like billing alerts that you can set up if you want to say, oh, I only want to spend like $10, $100 a month or something if you're just starting out, and then get alerted on that. So you can be across it. Yeah. Any other questions? Cool. Okay. Well, thank you very much for coming. I hope you learned something.